Hello friends, in this video we will talk about regression evaluation matrices. What is the use of regression evaluation matrices? That's we will try to understand in this session. Evaluation matrices are very important because using these matrices we are able to know what is the accuracy level of our model, what kind of accuracy is producing by the model. So there are several matrices, generally 4 matrices supported by ML.NET, which you can see over here: R square, MAE error, mean absolute error, mean squared error, and root mean square error. So if you are interested and you want to know more about these matrices, you can open this Microsoft uh, documentation portal, and you can see, if you go down, then you can see the matrices which is already offered by ML.NET. And R square is root square, that's the coefficient of determination, represent the predictive power of the model. So if R square values are near to 0, this means our model accuracy is really very high. If it's 0, this means the model is vague, it's not producing any good output to you. So you have to look into your data, or you need to retrain the model. And then there are three more error: MA, mean absolute error, mean squared error, then root mean square error. These are the matrices. So these matrices are in generally non-negative, in the negative areas, and the 0 would be higher for other matrices, as opposite to your R square error, R square values. So we will have a look over the R square values and others as well in our practical session. Let's walk through this. For the simplicity, what I did in last session, we have used the housing price CSV file, which contains many columns. So in initial level, I understand it could be difficult for you guys. So to keep it simple, I have salary CSV data here, which contains only 2 columns. One is years of experience, and another is salary. So we will import the year of experience, and then we predict the salary from our model. So for this, you need to create a data model class. So that class I created because there are only 2 columns. So then years of experience and the salary prediction. This is a score, as you know. We need a score, or we need one more class which predict the value to us. So this is basically salary prediction class. You can use any as per your convenience. So here I created another IPNB file. So let's do one by one. Initially, in earlier session we already did it, so I will copy the sum of the content here to save our time. So first we need to import the namespaces. Let's add the namespaces over here. Execute this. This will give us the data, and then provide the reference of our DLL, which the C# project we created over here. Let's execute this one by one. I will walk through one by one. Let me turn off my video so you have better clarity. Okay, now we load our data. As you are aware, this is the data we need to load in the ML context. Here we already changed the class name, salary data, and then salary data.csv. Load this CSV. Now the CSV is already loaded. Once the CSV is loaded, you need to copy the pipeline. So we will define the pipeline over here. I already prepare the pipeline. Let me open it. So the pipeline for our 2 columns, the way we concatenate the years of experience and salary in a feature column, then we perform the min-max normalization. As you already aware about this, I have done in the last session. If you are new and watching this session first time, please look into the comment. I will give you the link of previous video where you can watch what is the min-max normalization is. So this is the outliner that we have to perform. we need to scale our variable, scale our column, and then the new column would be a feature column, and then we will add a trainer here, the regression trainer. I added SDCA. I will explain these all the trainers for regressions in the next coming sessions. So for now, let's take the one of the trainer, and then input column, we have label column is salary here, and then prediction column that we treated as the feature. So execute this, and then now our pipeline is ready. We need to split and test the data. So the 30 rows data, we will treat 80% of this data in a training and 20% of the data in a testing. So here we will split our data set into two portions. One is training and one is testing. Now let's copy this. We will train our model. Here we train it with a train data set, and then copy this evaluation. Here we will train and then we evaluate the model with the test data, and then we will evaluate. So here our test data is not price, its column is salary, because we use the salary database. And now I will copy the matrices which are exist here. These are the evaluation matrix which will gives you the detail. So here we have R square error, MAE mean absolute error, RMSE mean root mean square error, and then MSE mean square error. So let's have a look. What is wow, that's very nice. So what you can see, R2 is 99%. This means our model is fantastic. It gives a very accurate result. So the prediction would be 99% accurate based on our data. And then MAE mean absolute error, RMSE mean square error, MSE. Okay, fine. So I think we should not be surprised, because mean absolute error and root mean square error, what we can see, the deviation is round about 1700. So the model is not bad. Our model gives accurate value. So the range, if you wanted to describe to the management, let's say what is the accuracy of a model with this data, then you can predict at the target. Let's say the range, it will start from, there would be the variation round about 1500 to 2000 in the salary range. That's not higher number, because the salaries, if I look into the salary data, you can see it start from 39,000 to 1,21,000. So between this range, 40,000 to 1,20,000, if our model gives us the accuracy plus minus 2000 or plus minus 1800, I would say that's fantastic result given by our model. So this is the evaluation matrix, guys. I hope you will do the practice more and learn more. Thank you very much. See you in the next session.